Good day, folks. Welcome to my YouTube channel. I'm doing the photoelectric effect question. This is a preliminary exam, which is the trial exam of a Free State province in 2016. Right? It says here a learner investigated the photoelectric effect with the use of the photocell. This is the photocell. And the photocell is irradiated by the light with a different wavelength as shown. So this is the photocell. This is the photocell. So this is the light that is radiated there. So when they say light with different wavelength, that means with different energies with different frequencies, right? So the light is incidented here in this metal, and there are electrons that are ejected there from the surface of that metal, which is the photoelectric effects that take place. And then this is a transmitter, and this is a receptor. So this is accepting the electrons, and then the electrons, they flow here. So the flow of electrons here per second, we read what we call it a current there, right? So guys, the electron, they'll flow this way. This is the positive. You take as if the negative will be attracted to the positive, and the negative will repel. So there will be the flow of current there. Now it says define the word photoelectric effect. The photoelectric effect, guys, you must define it according to exam guideline, is the process whereby the electrons are ejected from the surface of the metal when radiated by a light with a suitable frequency. Check the exam guideline. It says 10.2, it says the wavelength of 3 sources of light are shown in the table below. So we have different types of light here. We have a blue light, we have a violet light, we have an ultraviolet. Guys, if you remember the Roy GB, which is red, orange, yellow, green, blue, indigo, violet. So these lights, starting from red to the violet, they increasing in what? In frequency. The frequency increases from red to violet, and the energy is what? Is increasing, and the wavelength is what? Is the wavelength is becoming what? Is becoming shorter as you move from red to orange. But now the lights that we're given here, it starts from blue to violet. It's blue, indigo, violet. That means the one with the strongest energy is this one. So what we'll do here, from down, from up to up to down, from blue to violet, the energy what? Increases. From blue to violet, the frequency increases. From blue to violet, the wavelength is becoming what? Shorter, right? Very important. Very important that you must remember that the energy is directly proportional, is inversely proportional to wavelength, and the energy is directly proportional to frequency. Okay, I think let's move to the question. It says the threshold frequency of the metal used in the photocell, which is this metal, the threshold frequency for that we're given is that the threshold frequency, remember, is the frequency, the minimum frequency that is required by this metal here. So is that. Now it says the average speed of the emitted photoelectrons is 2.78 times 10 to the power 5 meters per second. So we're given the speed of the ejected electrons, which is the photoelectrons. Now question 5, it says identify the light used to irradiate the photocell. So which light is used here? If we are given the threshold of the metal and the speed of the electrons that are ejected, which is these electrons here that are ejected here, we're given the speed of them. So which light between these light has done the photoelectric effect, has ejected? So we're going to calculate the wavelength. Once we get this wavelength, that means it's ultraviolet. Once we get this one, that means it's violet, and this one, that means it's blue. So what are we going to do? It's 10.2. In 10.2, what are you going to do? We're going to use the formula that says energy of the photon is equal to the work function plus the maximum kinetic energy. So here we want the frequency, we wanted the wavelength of the light. So it's gonna be, we're gonna expand this into Planck's constant times the speed divided by the wavelength. This is the wavelength that we want. So the work function, are we given the work function? Yep, we are given the work function. No, we're not given the work function, we're given the threshold frequency. So that means we're going to expand that into Planck's constant times to the threshold frequency, plus we're given the speed, so we can get the kinetic energy there. So it is going to be, going to expand the kinetic energy, mass of the electron times the speed of the electrons, which is the photoelectrons. Then we substitute it there. So it's going to be there, Planck's constant is going to be 6.63 times 10 to the power negative 34. You can get at the back of the data sheet. And then the C, which is the speed of light, you can get at the back of the in the data sheet. And then we divide, and then that's our unknown. And then we are here, we're going to have 6.63, that's the Planck's constant, which is the H, negative 34 times the threshold frequency. The threshold frequency, it's 6.45. 6.45 times 10 to the power 14. And then we are done here. We're going to the kinetic energy. So it's going to be half the mass of the electrons, guys. It's 1.11 times 10 to the power negative. I forgot the value now. I forgot the value. It's negative 31. Negative 31, the mass of the electrons, guys. You get it from the data sheet. And then we times by, okay, let me move this just a bit. Yeah. And then we times by the speed. We were given the speed there. The speed is 2.78. 2.78 times 10 to the power 5 is positive 5 squared. Don't forget to square. Guys, if you do the math here, you get the answer of this, and then this answer, and then you cross multiply. When you cross multiply, you have this answer times this, and then you have this times by 1, and then you divide this by this, you get the lambda. You get the lambda. That's the easy maths, guys. I'm not going to dwell on that. So our wavelength there, it's going to be 43 times 10, 430. Your answer must be in 2 decimal place. 430 times 10 to the power negative 7 meters. So which one does it corresponds to? Obvious, with the ultraviolet, right? It corresponds with the ultraviolet there, all right? And then if it corresponds with the ultraviolet there, so which is it's 4.3, right? Then it corresponds with that. And then let's go to the next question. The next question in 10.3, will say, therefore the light used is what? Is ultraviolet, which is, it's a UV light. The ultraviolet is UV light, guys. Right. And then if we go to the next question, there, okay, guys, here this was the threshold frequency is to the power 14. It's to the power 14 in there. I've made a mistake, so we're done with that. Let's go to 10.3. It says the intensity of the incidented light is increased. So when they talk about the intensity, guys, you must know they talk about the brightness, which is the power. The brightness and the intensity of the light is the same, and the power is the same. Now it says, how will this influence the following? The ammeter reading, how will this influence the ammeter reading? So the answer here, guys, it's gonna be I didn't move. The answer here is gonna be increase, guys. When the brightness, the intensity is directly related the intensity of light is directly related to the what? To the current, and also is directly related to the number of what? Of photons. Number of photons per unit time. Which is when we talk about the current, we talk about the number of what? The number of photoelectrons emitted per second. So the intensity, when you increase the intensity, you are changing the number of photoelectrons emitted per second, or you are increasing the number of photons, not photoelectrons, the photons, which is the energy packet per second. All right, so the answer is going to be increase. So remember, the current is the number of electrons, so they're asking the ammeter reading, which is the current, is going to increase there. Now 10.3.2, it says the kinetic energy. Guys, the only thing that the brightness the only thing that the brightness increases is these. It's these. So the kinetic energy will remain the same. So the answer is what? Stays the same. Now they say give an explanation for your answer in 10, which is give the explanation why it's going to remain the same when you increase the brightness there. Guys, the only thing that you can say, it's this explanation that I've given you. You will say here, the intensity increases the what? The number of photoelectrons, right? The number of photoelectrons per second or per unit time, right? Or you can say it increases the number of photons, not. So you can say, guys, I'm not going to write it. So the intensity influences the number of photoelectrons emitted per unit time, and also the number of photons per unit time. That's what it influences. And then the next thing that you can say, you will say another thing you will say there, you will say the intensity does not influence the kinetic energy, right? It won't influence the kinetic energy. It influences these two things. You can state one of it, and then you say it does not influence that. So the only thing that influences the kinetic energy is the energy of the light, or the frequency, right? Guys, I think I should write it, but it's gonna take us forever. I don't like writing. 10.3.3. You will say the we're here at 10.3.3. The intensity of the light is only influence only has an influence on the number of photoelectrons emitted per unit time. Right, which is, that's 1 mark. Remember, that is 2 marks. That's 2 marks. And another point that you can say, the intensity, guys, I don't like writing sentences. The intensity of the light has no influence on the kinetic energy of the photons, right? Or you can say the only thing that influences the kinetic energy is the frequency, or the energy of the light when it's changed, right? Let's go to another question, the last question. It says that the light emitted The light emitted by a gas charged tube is used as a fluorescent light to produce the line emission spectra. Briefly explain what type of spectrum is this one. Guys, to explain this, they already stated that this light that is emitted by the gas is used as a fluorescent light. The fluorescent light, guys, is a type of light that produces the emission, which is it's a type of light that is released by the gas. So when the light is released, guys, which is it's an emission line spectra, which is in 10.4 they said explain that, guys. The emission line spectra, as this is the key word here. This is the key word here, the emission line emission spectra, which is that there's an energy released, which means the electrons, they coming from the higher energy state to a lower energy state. So you will say here electrons, but in full words, guys, they are from the electrons, the electrons they move, okay, let's say electrons they move from excited state, which is the excited state, which is the higher energy level, right? Higher energy level to okay, let's say back to the ground state. What is the ground state? The ground state, it's the lower energy level, which is the stable state, the most stable state, guys. And then the next thing that you say, the energy is radiated as light. So radiated, which means that this type of energy, guys, is given off as a light, guys. This is like this. This is like this. If you have seen this, let's say this is energy level 1, energy level 2, energy level 3. The electrons, they coming from there, which is, what is this? This is the excited state, and they going to the ground state. Remember, the energy, the excited state, I said it's a higher energy level, and the ground state, it's a lower energy level. So the electrons, they move from there to there, right? So as they move from there to there, they're coming from the excited state to the lower state. So we call this type, it's a line emission. What? Spectra. If they move from higher energy level to the lower energy, it's a line emission spectra. So whereas they move these electrons from the higher energy level to the lower energy level, they what, as they say here, the light is emitted by a gas, which is used as a what? As a fluorescent light. So they give off the fluorescent light. The type of light that is called is a fluorescent light. Guys, this is an explanation. We are done with this question. I hope, guys, I make sense. Cheers, bye.